In this video, we're exploring one of the applications of fundamental theorem calculus, that is finding areas. So if we look at this graph or these pictures right here, if we're about to find the area of the gray regions, how can we go about it? First, I want to look at the pictures, right? And I want to identify some lines or curve that forming this picture. So first I have a line here, let's say y equals to 4. I call it as a function's f of x equals to 4. I label it. And I have a curve, a blue curve right here. Then I go ahead and figure out the formula for this blue curve. And it turns out the formula for this blue curve is square root of 0.5 plus x squared. And I call it the function g of x. Okay. And then look at this circle. So this circle has a center at 0, 2. It has the radius of estimated square root of 0.3. So I know the circle formula, it should be x squared plus y minus 2 squared equals to 0.3. Okay. And then I can try to figure the functions that describes the upper half of my circle and the function that describes the lower half of my circle. So I call j is the upper half functions, and then k is the lower half functions. And using the circle formula, I would be figured out j of x equal to square root of 0.3 minus x squared plus 2. And k of x is negative square root of 0.3 minus x squared plus 2. So now that I have all the functions that I need to define, I can use the fundamental theorem of calculus to find the area of these gray regions. First, I want to find the area of this square, this big square. And the area of the big square here is actually the area under the curve f of x above the x-axis from x equals to negative 2 to x equals to 2. Okay. And the fundamental theorem of calculus say this area here is described using the definite integral from negative 2 to 2 of the function f of x dx, and it is 16. If you don't believe it, you can find the area of this square using the square formula, that it is 4 square, because the length of each side is 4. 4 square is 16, 16, 16. So this both areas match. We're good for now. Next, I want to find the area of this blue regions right here. So this blue regions is the regions under the curve of this blue curve above the x-axis, and again from x to equals to negative 2 to x equals to 2. So I can use definite integral to find this blue region, the area of this blue regions. And it is right here. So I take the the integral from negative 2 to 2 of the function g of x, d of x, and I get 5.124. Okay. Now, once I have the area of this big square and I have the area of this blue regions, I can use indefinite integrals to find the area, this gray area here right now, including the circle, the area of the circle, right? It's gonna be equals to integral from negative 2 to 2, right, of f of x minus g of x dx. And the area is 10.87598. All right. So the reason why I'm taking f of x minus g of x is f of x on the interval from negative 2 to 2 is always greater than g of x. Okay. F of x is always greater than g of x on this interval. So that's why in order to find the area in between these two curves, I need to take f of x minus g of x integrated from negative 2 to 2. Okay. I get 10.8759. Now we move to find the area of this red circle. First, I want to find the area of the upper half of this circle. And you can see that I use the function g of x to describe the upper half of the circle. And this area here is actually the area between this curve g of x and the line y equals to 2 from negative square root 0.3 and positive square root 0.3. So using definite integrals, I can set up a definite integrals from negative square root 0.3 to positive 0.3, and I take g of x here minus 2 d of x to get the area of this upper half of this red circle. Again, I take g of x minus 2 because on this interval, g of x is always greater than 2, or at least 2. So that's the area of the upper half. And we're gonna find the area of the lower half, and as you expected, the area of the lower half should be equals to the same, to the area of the upper half, right? And then in order to find the area of the lower half here, we need to set up a definite integral from the same bounds, negative square root of 0.3 and positive square root 0.3. But this time we take 2 minus k of x dx, because on this interval, 2 is always greater than or equals to k of x. And as you can see that the results for the two halves are the same, which rest assured that we are doing the right thing. Okay. And since we have the two halves, you can just take 2, multiply to 1/2 to get the area of the red circle. And to make sure that we getting this definite integrals correctly, I can try to use the formula to find the area of this circle, pi r squared. And I take pi r squared, I get the same result as the result that I used from definite integrals here. All right, now the last step is we just need to find the area of the gray regions. We found the area of this big gray regions. We found the area of this circle, which is if I call A is the area in between the purple line and blue curve, and C is the area of a half of the circle, then the area of the gray regions is A minus 2 times C. You get 9.9335 is the answer. Now that you just learned how to use fundamental theorem of calculus to find the area of interest. Once we can set up formulas, or we can set up, when we can define functions for other curves, then we can use definite integrals in order to find the regions in between, so then we can find the area of interest. I hope that you find this videos useful. Have fun.